Welcome everyone to this high-octane revision explainer. Look, I know the pressure is absolutely on right now, and the clock is definitely ticking, but just take a deep breath. Think of me as your academic coach for the next few minutes. We're going to go on a last-minute math sprint, covering the absolute essentials of algebra and geometry. By cutting through all the noise, we're going to lock in those crucial concepts and make sure you walk into that exam room feeling sharp, confident, and completely prepared. And most importantly, we'll see how these aren't just a bunch of isolated tricks, but a deeply connected web of foundational math skills. Okay, let's dive right into this.
So, here's our game plan for today. We'll start with a rapid math sprint to build the foundation. Then, we're nailing geometric proofs, mastering the algorithm for completing the square, finding intersections with simultaneous equations, and finally, covering a literal lifesaver, always checking your answers. Let's tackle them one by one.
Section 1. Last-minute math sprint. Building the foundation.
Now, as we shift into this last-minute exam mindset, it's completely normal to feel a bit of pressure. But I want to reassure you right now, you already have the core tools you need to succeed. We really just need to make sure they're sharpened and ready to deploy. As the team at Resourceaholic puts it, building a solid conceptual understanding of algebra is absolutely fundamental. It's just like learning how to work with fractions. If we don't get this core mechanic right, everything built on top of it kind of gets shaky. You literally cannot solve advanced geometry without a firm grip on algebra. It is the absolute bedrock for conquering the rest of this exam, whether you're solving complex quadratics or evaluating physical quantities. Lock in the basics, and the rest absolutely follows.
Moving right along to Section 2, Nailing Geometric Proofs, the Chain of Reasoning. Let's look at how our foundational logic builds straight into geometry. A geometric proof is not a guessing game. No way! It's a highly logical, structured chain of reasoning. Sometimes the exam doesn't just want the final number, it demands that you prove exactly how you got there. When we're asked to find an unknown angle, like angle IHG here, we can't just jump straight to the answer, which, by the way, happens to be 50 degrees. We have to start with the knowns. We're given two specific anchor points, 60 degrees and 110 degrees. From those two anchors, we've got to logically deduce the next angles in the sequence, showing exactly how we reasoned our way from the given info all the way down to that final 50-degree mark. It's like a giant puzzle.
So how do you actually write this down on the page to secure full marks? Well, here's your foolproof, step-by-step method. Step 1. Start with the angles you are given. Step 2. Deduce the next immediate angle in the chain. And Step 3. Okay, pay close attention here, because skipping this is how so many people just throw away easy marks. You must state the theorem you used, in brackets, right next to your deduction. Writing just the number is simply not enough. The examiner needs to see the geometric law you used to get there. Use the therefore symbol, those three little dots, and clearly label your reasoning, like writing X angles, H angles, or D angles in parentheses. You just repeat this chain logically until the last step gives you the exact angle you want.
All right, Section 3, Completing the Square, the four-step algorithm.
Grabbing the next tool in our tool belt, let's talk about a truly powerful algebraic technique. It's primarily used to solve quadratic equations, but our Math Center resources highlight that completing the square is also the perfect method for finding the maximum or minimum values of quadratic functions. Let's clarify the overarching goal here. When a quadratic expression isn't naturally a perfect square, we manipulate it. We're basically rewriting it into a complete square form, which looks like x plus a all squared or x minus a all squared, followed by a plus or minus constant hanging out on the outside. We aren't changing the fundamental value of the expression at all, we're just reshaping it. And this isn't just some abstract exercise. It's literally how we find the absolute peak or valley of a parabola on a graph. It transforms a messy equation into a crystal clear geometric map.
To pull this off flawlessly every single time, you've got to commit this four-step algorithm to memory until it's completely automatic. Step 1, factor out the coefficient of x squared, so you're working with an expression where the x squared coefficient is exactly 1. Step 2, look at the coefficient of x in your new expression and take exactly half of it. That half number is what goes inside your complete square bracket. Now, Step 3 is where the magic happens. Balance the constant term. Why do we do this? Well, when you square that halved number inside the bracket, you're artificially adding value to the equation. To balance the mathematical scales and keep the equation perfectly true, you must immediately subtract that same squared value on the outside, and then plug the original constant back in. Finally, Step 4, do the arithmetic. Just combine those constants. Stick to this rhythm, and honestly, you can handle any quadratic thrown your way.
Next up, Section 4, Simultaneous Equations.
Finding the intersection.
Up until now, we've been pretty abstract with our algebra, but solving simultaneous equations is actually a geometric reality. This is where the whole topic really comes together. When you're asked to solve a pair of simultaneous linear equations, what you're actually doing is finding a common physical point. You are hunting for the exact specific geometric coordinates where two straight lines cross on a graph. The algebra is simply the mathematical vehicle we use to find that single point of intersection out there in geometric space.
Now, to find that coordinate without having to painstakingly draw a graph every single time, we rely on two primary algebraic methods. First, the method of substitution. This involves taking one equation, rearranging it so that y is completely isolated by itself, and then taking that whole resulting expression and substituting it directly into the second equation. Then there's the method of elimination. This involves a totally different tactic. You multiply one or both of the equations to make the coefficients of one variable match perfectly. Once they match, you add or subtract the entire equations from one another to completely eliminate that variable. Just a quick warning here for your revision though. When you're subtracting equations in the elimination method, managing your negative signs is literally your biggest risk. Be incredibly meticulous with your pluses and minuses.
Okay, both methods are totally valid. But lean in for this one, because here is an absolute insider tip straight from our Math Center source, and you should definitely take this to heart. The method of elimination is much better to use. Under exam conditions, it's generally faster, it's cleaner, and it's significantly less prone to those messy fraction errors that substitution can sometimes trigger. If you have the choice, absolutely prioritize the elimination method for maximum efficiency and accuracy.
And finally, Section 5. Always check your answers, the cool down.
We are officially nearing the finish line of our revision sprint, entering the final and honestly, perhaps the most crucial phase. You've done the hard math. Right now, you literally just have to protect your investment. In a high-pressure exam, silly arithmetic errors happen to absolutely everyone. So here's your ultimate, literal lifesaver checklist for verifying your answers, especially for simultaneous equations. Once you've found your final values for x and y, you are not done. First, take those values and substitute them back into the first original equation. Calculate it out and make sure the left side perfectly equals the right side. But, and this is a vital, non-negotiable rule, you cannot stop there. You must then substitute those exact same values back into the second original equation and verify the equality on both sides once again. Only when both original equations balance perfectly can you confidently move on, knowing for sure you've unequivocally secured those marks.
And with that, we've completed our sprint. Are you ready to crush this exam? Your mathematical tool belt is officially fully loaded. You've got the foundational logic, the geometric chains of reasoning, the algorithm for completing the square, the strategy for finding geometric intersections using simultaneous equations, and that crucial final checking mechanism to lock in your success. You now know that algebra and geometry aren't separate subjects at all. They're really just two sides of the exact same logical coin. So, when you sit down for that exam, are you going to just blindly crunch numbers, or are you going to use these tools to uncover the hidden logic right there on the page? Thanks so much for joining me on this explainer, and best of luck out there.